As I think, Sandeep, you've covered most of it. I was part of the Amazon India team, but before that, I also worked at the Amazon office back in Seattle, leading some of their worldwide platform capabilities. We were talking about AI, and I think there was a question around AI, and I think when I go back and say, when did AI really become something like AI? I remember back in early 2000s when Amazon started the personalization and similarities and recommendations. Back in the time, was probably one of the biggest and the earliest use case of AI, where systems were used to teach or train people on what to buy next. And since then, obviously, a lot of stuff has happened. Even personally, in my journey, moving from Amazon to Swiggy has kind of exposed me to very different domains, moving from an e-commerce domain with a lot of problems that were solved to now the hyperlocal domain that has a bunch of unsolved problems. So I'm here to just talk about my experiences, maybe talk about things that we have done and see if it resonates with you, and then we'll just take it from there.
So maybe we'll just start with that. I mean, the history and how you've seen it evolve. I mean, at the very beginning, it was a very simple thing. People who bought this, bought that. Yeah. And that was really nice. And that was such a good way to get people to do more things. How did it go from there to the next step? And what really was that next step? And where do you see it currently let's start in e-commerce and what's really changing in that?
So I joined Amazon in 2007. At the time, they had already launched recommendations. I remember the team itself was maybe 5 or 6 engineers with one manager. That was basically the team that was powering this entire capability for Amazon. I think the background there was a lot of the math already existed. The math around collaborative filtering already existed. The changes that happened was basically the amount of processing power that you could bring to bear and the data that you can collect that can allow us to use more complex algorithms over time. So a basic algorithm that basically try to match customers to another customers based on like similarities. So you've bought these items, she's bought these items. So maybe when she buys the next item, you may want to check it out. That's basically the logic behind collaborative filtering. We just try to match like pairs. But then when you think about more and more use cases, now you start to think about, but then you did something different because on that day you did something different and maybe there's a different need that you were trying to meet. So as you get more and more data, you start to realize that the use cases that customers are trying to solve for are many and varied. And now that you have those use cases in hand and you have the processing power, you can start to be a lot more granular, a lot more specific about what specific recommendation to give. So at the end of the day, if you look at the Amazon site, it still gives you a recommendation on what customers bought and what you should buy. But the way it does it, I think the amount of use cases it now thinks about is very different. Because it may look at saying that maybe today is a Thanksgiving holiday. So the recommendation I give you today is very different from the recommendation I give you on a regular day of the week. Or maybe you are sitting in Seattle and the recommendation you get because you are in Seattle is very different from the recommendation you get based in the Bay Area. So I think from a product capability perspective, the amount of precision and the accuracy that we've been able to bring to bear on these capabilities have increased over time with that data.
Do you have a sense of the order of magnitude impact on, let's say, conversion to people who bought this, bought that, based on the incremental data?
It's huge. It was at the time when it began just another feature that launched. But I think the last time they were looking at it was like a multi-billion-dollar product by itself. Just that one strip of recommendations gets 30% conversions on the site. So it's so precise that when somebody looks at a product and looks at the recommendations below, 30% of people actually click through and buy something in that recommendation. So that's a multi-billion-dollar product, just that one.
So obviously nowadays there's a lot of conversation about privacy and questions about how this data is getting used. And sitting at the center of creating this stuff, does that weigh on your mind?
Yeah, I think it's super important. I think where we draw the line, even at Swiggy, is essentially around saying we need to make sure we don't uniquely identify a customer. So I don't want to get to the world of saying, I know Sandeep, I know he's bought all this biryani, so he must really be a biryani lover, so then let me just target him with biryani notifications. That would be an invasion of privacy, right? But then when we look at data, and if I have 10,000, if I have 1 million customers in a certain area, and if I use the data in an anonymous way to be able to derive insights, that allows me to become smarter, but at the same time protects the identity of the customer. So a lot of our focus is on saying, how do we anonymize data of customers by trying to derive patterns from the larger base versus go down to the unique customer and try to be very specific in our data gathering.
So now let's take that to India.
Yeah.
And you obviously started over there. You saw it kind of grow and emerge. You came here. You again started from scratch, where you had the chance to build up a base in Amazon, and then you came over to Swiggy. And
Yeah.
now, I mean, Swiggy has a base of data as well. But maybe just talk about the contrast that you saw between where perhaps the US was at a time, then as you came to India, and how the market has evolved here.
Yeah, I think the biggest contrast that I saw, especially leaving Amazon India and joining Swiggy, is just the data quality in India is so diverse compared to the data quality in the US. The customers are not the same. In the US, you could be sitting in, say, the Bay Area, or you could be sitting in New York, and if you look up a book, you'll probably find the same recommendation on Amazon.com. Or if you look up a generic keyword like jeans, you'll find the same recommendation. But if I'm sitting in India, a customer in Chennai is different from a customer in Delhi. Or a customer in Punjab is different from a customer sitting in, say, Bengal. Right? So there's an extreme diversity in the data. So that's one of the first realizations we had, that we really need to think hyper-local in how we build products here in Swiggy. The second, yes, the second. I think the difference is also that in India, the data itself is extremely unstructured and sparse. So multiple use cases. We collect data from our drivers as they are driving through, on deliveries, and every 10 seconds we are supposed to get a ping back from their phone that tells us where the driver is. So we can use that to do things like route optimizations and planning and so on. Now drivers, every once in a while, turn off their phones because guess what? Their battery is low, so they just turn off their phone. So now you have a missing set of pings from a driver, and then boop, suddenly they come online. So you're trying to build like algorithms on top of that. With that missing data, the algorithm isn't able to understand what happened. Did the driver go off, or did something happen, or was there truly a reason why the driver stopped? And so that's where you've got to worry about saying, how do we fill in even gaps in terms of sparse data? How do we fill in missing information that isn't there? And how do we bring that in the India context?
And I guess maybe here as well, the scale that you're seeing now hasn't necessarily been seen in the past in many of these areas. Yeah. So, I mean, maybe you just talk a little bit about the numbers that you're already seeing in terms of data points and events that are going on.
Yeah. It's been an incredible, I think, lift. We started when I joined Swiggy. We were at 17 cities in India. In 8 months since I've been there, now we are at 100 plus cities in India. So we've kind of grown massive 5x in the last 8 months in terms of just the number of cities. We have India's largest delivery fleet. So there are around 125,000 drivers who are delivering across India, which is larger than any e-commerce player or any other food delivery player. We also have around 70,000 restaurants and millions of orders per day. So you think about that combination of all these different things, the amount of data streaming into our systems. At this point, we built our own data platform, and we are processing around 40 billion events per day. That's kind of 40 billion notifications, messaging, signals that we gather from different parts, which includes our drivers, our customer interactions on our site, and then the restaurants and the partners and all the activities they take. And we process all that into our data platform. And on top of that, we've built some of these ML models that then allows us to optimize that platform.
So we were talking a little bit about this before as well, this idea that 40 billion, I mean, okay, when is it enough? 50 billion, 60 billion, 80 billion, 100 billion? I mean, when does the marginal return start to plateau out and you say that, all right, I've got it as effective as this can be?
Yeah, so, and as I was saying to you, I think we've barely started to scratch the surface. Data is like the new oil at this point. Every company is just out there trying to gather as much as they can. And I think in the long term, data is going to become the proprietary asset that a company has, because algorithms are actually easy. Algorithms are actually public. A lot of the algorithms are off-the-shelf public algorithms, or mostly research-driven algorithms that are publications available online. But what really changes an algorithm is the application of the algorithm to that data that you have. And the data that you have is really what allows you to become more precise, more accurate, and better targeted with that. So I think at this point, we are just in the game of saying, let's just gather data. And then once you build that corpus of data on which you then have enough of content, then we can monetize that.
So, I mean, it's great because India has lots of data, right? We have lots of people generating lots of data. And again, as you look at sort of this race for who gets to mine the data the most and who gets to do the most with it, I mean, right now, the US and China are far ahead. And perhaps one of the best saving graces in this whole thing is, like you said, much of the algorithms are open source. So at least we have access to it here. But where do you think we sit on that spectrum? Because the challenge is, I'd imagine, that while we have data, do we have enough people that know what to do with the data? And do we understand how to actually process and think about it?
Yeah, I would say it's getting better. When I moved to India, I had to start the Amazon India AI team, and at that point, we did run into challenges with being able to find talented scientists who would be able to, kind of build at that scale. So then I ended up building a team in Seattle to work for the Amazon India problem space, but sitting out of Seattle because the talent was there. So we had a team both in Bangalore and a team in Seattle. But then over the last few years, I think a couple of things.
I just want to interrupt you there. So how did that work? Did the guys in Seattle get the context? The driver turns the phone off, that this happens, that happens, all these things.
Lots of late night conference calls. Yeah, that's how we set the context. And of course, I was traveling every 3 months. I would travel to Seattle. But yeah, it was essentially a very diverse team. We had a bunch of Chinese scientists working for the India problems. We had people from Ukraine. We had scientists from Poland. So it was one of those international teams working on trying to solve India problems, but sitting out of Seattle. It was crazy. But we got a lot of stuff done because, to your point, the talent was there. And the talent was hard to find in India. But over the last few years, I think what has changed is we're seeing a lot of talent come back to India. In Swiggy, for example, the people I've hired are largely people who've done their PhDs in the US, who have worked there and are now coming back. So a lot of the senior folks are coming back after having worked 10, 15, 20 years in the US. And that's adding to this layer of depth that we didn't have for a long time.
If you kind of think about it as a more India challenge in general, do you see any light at the end of this tunnel? Do you see any effort being made to cultivate? Because again, if you look at what China did over a 7-8 year period, they made a very concerted effort to basically educate a mass of people in all the relevant skills around data science. I'm not sure I'm seeing that here yet. And do you think that's going to happen?
Yeah, I think there are two aspects to it. There is the person who can build a new algorithm, and there's a person who can apply existing algorithms. I think the person who can build an algorithm is like a PhD, like a doctorate, somebody who really understands the depth and can design new algorithms. I think that's where India still has a lot to do and to catch up. China has, I think, the second largest PhDs in the world behind the US. And so that's a big lead they have. But then when you look at being able to apply algorithms, that's where we really have a lot of smart engineers. So the people that many companies are hiring are even people who have done their masters or even people, smart engineers from like IITs or triple IITs who've come out and who can actually understand enough of the science to be able to apply the algorithms. So where we, I think, have advantages, the number of people we have to be able to deploy and being able to apply data to existing algorithms. Where we may struggle is in deep tech, where we are trying to build new algorithms, and that's where I feel the number of people who can do that is limited in India.
So every time a new trend or wave comes, it becomes the thing of a company to start to talk and do something about it. So whether that's design thinking or e-commerce or mobile, or suddenly everybody's got to be working in that direction. Now with AI, we often get asked, are you going to invest in an AI company? And I kind of look at it and say, every company needs to be applying and thinking and doing this, which means then that every team needs to be doing it in a certain way. So when you stepped into Swiggy, like you said, it was at a certain scale. I'm not sure how deep necessarily the AI thinking was at that point. How have you seen it evolve, or what has worked to actually make it be an integral part of how the team thinks?
Yes. I think when I moved to Swiggy, Swiggy was at the time a 4-year-old company. In fact, they just completed their 4-year anniversary the week before I joined. And a lot of the systems and the product was built on human intelligence. For a long time, for the longest time, they were just in 4 cities, getting it right. And then they moved to around 17 cities. But even at that scale, you can manage a business through people. And so you can learn from on the ground, and you can tweak systems, and you can set these business rules and magic numbers because you just have people who understand the business deep enough. But then when we kind of looked at our expansion plans, and as we said, we moved from 17 cities to now 100, and maybe we're going to go a lot more in the next 12 months. at some point, you just cannot scale, right? So AI isn't a fad for us at Swiggy. AI is a necessity. It's an existential need that we have. Without AI, we just cannot process the amount of information that we need to process to be able to make business decisions. The number of moving parts at any given point in time right now, there will be close to around 30, 40, 50, 60,000 drivers driving around, and at peaks, many multiples of that. So at a dinner peak, you can imagine trying to control this network by hand, where every time a customer sees a 5-minute delay in their order, they're calling someone, and we're trying to manage that. That kind of network cannot be managed by hand. So in some sense, it became imperative for us to become an AI-first company. The things we did was, I think we began with the top. The first thing is we actually set up a training for leadership. I called it the ML 101 training, which was delivered by my own ML team, but we had all the senior leadership have a 4-hour training on just what is machine learning, why is it important to the business, how do you know when to apply machine learning. The second thing we did was we took goals to say, how do we make sure machine learning is part of the company's goals? Where it's not just about data scientists, it's about, can we build products that are intelligent? So if tomorrow there's a goal that says I need to launch X, we would essentially go back and rephrase the goal to say, launch X using machine learning as the solution. So in some sense, you force people to go out of their comfort zone and start thinking about how do I adopt machine learning, because that is the future.
I guess when we did this conversation on blockchain, a statement that came out from someone was, blockchain is the answer, now what is the question?
Yeah.
And do you think there's a risk here that, now with this mindset, okay, let's do this, now let's AI it. We'll AI this. People might not even know what that means, but we're going to make it AI.
Yeah.
And so is there a risk of overcorrecting? Is there a logical point at which you say, listen, you guys should just do this normally, don't worry about it, and we'll take care of this stuff over here? How do you break that?
Yeah, we have those conversations all the time. It's a case-by-case conversation. For us, at least for me, machine learning is like a tool in the toolbox of things you can do. So in terms of the maturity of a problem space, machine learning could be the last thing you may take up once you've exhausted all the existing tools you have. Simple tools like just human judgment. You can start with a basic rule that may just be good enough most of the time. Or you could have some kind of basic business analytics-driven rules that can be derived from statistical analysis of the data, right? So you don't really need to use machine learning. I think the time, though, the tipping point between when machine learning becomes super important for us is where the decision-making time is so short that to then expect a human to make that decision in real time and make them right is extremely hard. So
I think, again, maybe the conversation around how scale just doesn't, humans don't stack up at scale, right? I mean, the whole notion that the probability they're going to get something wrong is there.
Right. We're talking about this, and I was talking about an example where we have our own kitchens, where we also sell on Swiggy as a private brand. I had ordered food from one of those kitchens one of the days in office. I'd ordered for fish, and I received a bowl of chicken. So I walked over to the guy who runs the kitchen, and then we just said, let's go down to the kitchen and see what's happening there. So this is a 6,000 square feet, facility with like a bunch of people, and there's the order that comes in, and then people just put stuff into the bowl. And at the end of the line, there's this guy who's standing, who's physically looking at the dish, and he looks at the dish and says, "This looks like fish." So he sticks the fish label on it, and then off it goes, right? So now that person is your bottleneck. Now that works very well when you're doing 20, 30 orders an hour, where this person can get the time to eyeball every item and maybe let it through. When you start to now 10x that scale, when you're doing like 300, 400 orders an hour, which is literally 5 orders every minute, that person will not have the time to be able to maybe look at it very carefully. And that's when probability hits in, where like we talk about humans being 3 sigma machines, where we may get things wrong 3 times out of 1,000. And so when you do that at times, the person at that counter is going to make a mistake and is going to call fish chicken and send it out to the customer. Worse, he may send chicken as paneer to somebody who's a vegetarian and really cause like a social media scandal for us, right? So that's a place where we start to then think of how can we use machine learning to replace the human process with maybe a system that is more reliable and more precise. And in that example there, we are actually right now experimenting with putting a camera in the kitchen where we can take a picture of the bowl as it's ready running through the line, and then using machine learning, deep learning, and edge computing, be able to tell the person that this is actually not the dish that it was supposed to be. So if I take a picture of a lot of fish bowls, at some point my machine will figure out what is fish and what is not fish and then be able to flag it in real time.
So making the food is one. Now getting it to people is another game altogether, right? And I think in general, with the advent of Uber, Ola, delivery services, a big question around traffic growth and what's happening there. And I imagine for you guys as well, getting it from here to there effectively is really important.
Yeah.
And so here again, we were talking about how applying AI, applying machine learning, you've been able to figure out things and some of the interesting, strange occurrences that took place as well. And I guess one of those counterintuitive situations that you were talking about where you wouldn't have thought that this would happen, but I guess it speaks to the point that entrepreneurs are everywhere and the drivers are entrepreneurs as well and how they look at things. And so managing their entrepreneurial efforts becomes a challenge also. And this has helped in a way there as well.
Yeah. We were talking about this from a delivery perspective, and we were talking about how as we start to collect data about our drivers, we also start to predict the time it will take for the driver to reach the restaurant, and also the time it will take to reach the store. So now, if we predict that, when you go to the app, you'll see 20 minutes. That's basically the AI model saying, based on the distance and based on all the information we have, this will take 20 minutes. But what we saw with the data that we started to gather was that sometimes some drivers would take a lot more than 20 minutes. And it would just look like the algorithm was wrong. And so we started looking at the data and we realized that because drivers are paid by the minute, some drivers just decide to take the longest possible route before they can reach the customer location because it's essentially running the clock. And you also saw use cases where other drivers would actually have this kind of collision where we are both drivers and we are both friends. I'm sitting in front of this restaurant. I place an order to the restaurant. You go pick it up, and then I go cancel it, saying I didn't receive the food. So I get a refund from Swiggy, and he gets the free food. The restaurant basically gets a refund from us. So Swiggy pays everybody in this equation, and the driver gets free food along with that. So I think those are kind of the insights that data gives you. Once you start to process your data, once you start to understand the data and derive patterns, a lot of these insights that we would never catch by using humans on the ground. And the only way you would catch it by being able to process data and derive insights.
And so now we can see its current use cases, but as you kind of look forward a little bit more, where do you see it in the food space now? Where are you guys saying, wow, if we could really get there, that would really shake things up in a massive way?
Yeah, I think we mentioned perceptive AI. I think that's one of the areas we are looking at it. Autonomous AI would be hard in food because that could probably be weird if you just got some random dish show up at your desk. But perceptive AI is interesting where we want to be able to understand what the customer needs even before they state that need. And a classic example of this in a smaller way is like the Netflix use case, where you're just feeling like watching a movie and then you open up Netflix and then it tells you, here are some movies based on a Friday night watching or binge watching movies, or here are movies that you may like from a horror perspective or comedy and so on. Similarly with food, I think one of the areas that we haven't done a good job so far is being able to provide the serendipitous discovery for food. Swiggy is a very functional app where you go in, you know what you want, you buy it, and then you're out. But we want to bring some fun into this equation where I want customers to be able to come to the app and say, I'm just feeling hungry and give me options, right? And we should be able to understand food. For example, if I understand that two dishes have the same ingredients, maybe they both are having methi as a common spice, or maybe they're both baked as a common preparation style. Can I link them together so that I can provide you that recommendation where you just like something that is baked, then I take you in this journey where I show you more dishes that allow you to then find and discover new local favorites. That's what we call the food graph. It's something that we are looking to work on. Food graph is the equivalent of social network, but for food, where we link food dishes together and relate them based on the information they have, the cuisine style, the calorific value, the ingredients they contain, and so on. And then allow that food graph to then help customers navigate food.
I could just see the future. That how many likes does this food have? How many hearts does it get? All that, right?
All that just feeds into who gets that next dish as a recommendation.